All right, in this part 9 of chapter 5, we are going to talk about percent composition of compounds. It is a list of percent by mass of each element in a compound of whole molecular mass. You would calculate by using the formula, using this formula of identifying the percent by mass of an element as n times the atomic mass of a element that you're trying to identify percent element for over the entire molecular mass of the molecule or formula compound, multiply with for 100%. What is the use of it is you might sometimes can use it as an application in trying to identify the density of a compound. If you have two different compounds, just by knowing which one of the element is in higher percentage, you could identify the density of that particular compound. That's one application that I can think of right away. There could be many more for this concept. Let's see what's the use of it and how to identify it, if not the use. For a molecule of H2O2, what is the percent composition of hydrogen and oxygen, okay, in its entire formula? Again, this is the formula that we use to identify percent composition of each individual element. First, let's identify for hydrogen. There are two hydrogens, and the whole molecular mass is happen to be 34.02 atomic mass units. So 2 times of hydrogen atomic mass, 2 times of hydrogen atomic mass over the molecular mass of H2O2. So if you calculate the percent of hydrogen, only 5.9% of the mass is from hydrogens. And for oxygen, there are two of them in H2O2. So 2 times 16.0 over the entire molecular mass of H2O2. So it happened to be 94.5%. That is how we would identify it. Maybe, if you want to take it as an, let's say, application, you can take the percent composition of H2O, each hydrogen composition and oxygen composition, and compare one with another, depending on which one has higher composition of oxygen. You could use something like that. Remember, we discussed this topic called empirical formula. Empirical formula can be useful here when you try to identify percent mass by composition. In H2O2, you have two hydrogens and two oxygens, and in HO, HO is the empirical formula of H2O2. And even if you identify the percent composition for just OH, you would end up with the same ratio of percentages of hydrogens and oxygens. So it's just kind of a shortcut to identify percent composition for large molecules. If you know the empirical formula of small molecules, for example, if it is given in a competitive test for you, you don't want to spend lots of time on trying to identify for large molecules by doing large math. You just need to identify the empirical formula, smallest ratio, then identify the percent composition quickly and get the answer and move on to next question. This is kind of shortcut that you might need to use in future. Okay, let's work on another problem. Lithium carbonate, which is a mood stabilizing drug that is used to treat bipolar disorder, that is having the formula mass of Li2CO3. It is asking us to calculate the percent mass composition for each of the elements that is present. There is a lithium, there is carbon, and there is oxygen. Let's see if we can identify percent composition for these elements. The formula is we just saw previously, which is m times that particular element atomic mass over the entire molecular mass of Li2CO3. Li2CO3 has the overall mass of 73.89. There are two lithiums with the atomic mass of about 6.9. So you have about 19% of lithium present in it. Let's calculate for carbon. There is only one carbon, so 12.01 times 73.89 again. So you have about 16% of carbon. And for oxygen, you have three of them over 73.89. You have about 65% of oxygen composition in that. Whenever you calculate this, just make sure you have a total of 100% because that's all has to be accounted for. All of the molecular mass in one or another. So it has to be equal to 100%. That's all you need to make sure, just to make sure that you did it right. This is all for this topic, very simple topic again, percent mass composition. Just to know, where is the mass is coming from, which is the most predominant element in a molecular formula. I'll see you again in the next topic, the last topic of this chapter, part 10.